Hello guys, welcome back. Uh, First thing, in this video we're going to explain OSPF multi-area, and we will discuss about multi advantages with multi-area and what is the main why we do multi-areas instead of one area. Okay, before going jump into the multi-area, we will discuss about in a previous video what I gave you one assessment to sort it out to try communication from PC1 to PC3. If anybody not watched that video previous video, please go and watch it and try yourself to sort out OSPF communication from PC1 to PC3. If you are not success, or I hope you will solve the problem. What is the problem in the router configuration? What is the problem with the OSPF configuration? Okay, if anybody is not success, please we will go through now. If you solve and if you successfully communicated from PC1 to PC3, please skip this step. I will put the timestamps in description. Please jump on to the your next OSPF multi-area. Okay. Before I'm just whoever not done this one, please try again. Otherwise, we will walk through the step by step now. So here is our is router 1. This is I am on this is router 2. So first I will check what is why we are trying to go from PC1 to PC3. First I'm ping. What is the PC3 IP address is 192.168.40.5. So we will try that one. 192.168.40.5. So I'm not able to ping that. So first we not reachable even there. So oh, so you see that even we are not reaching our gateway also. First we need to check what is wrong with there. Okay, then we will check step by step. First we reach the gateway, then we will reach next router, then we will reach next network. Okay, first show what is the IP address we configure here. Show IP. So we configure .5 and our gateway is .1. So we will go here and router 1 now. So we will check show uh, interface. What is the interface? We have to check actually how we configure this interface, how we configure that. Show IP interface gig 01. Okay, when you see first thing, this is administratively down, so line protocol is also down, so that means the interface is not up. So we have to bring that up first. So this is address we configured, we did everything fine, but the interface is not up. So first thing we have to try that. Okay, going to jump onto config 1 now, config t, and interface G01 gigabit 01. Okay, we have to bring that up. No shut command will bring that interface up, so that is up now. So that is one thing is fine now. So we will check is our PC is reaching now. So go here and ping again 40.5. Okay, still not success. We are going up to .1. So you see that this is we received .1 and we are not going to reach host unreachable. So that means we are not going. So try that trace route. Sorry, we will check what commands available on this PC. Okay, trace host, trace 192.168.40.5. Okay, so it is going up to 10.1. So you don't know anything about other networks here. So we have to check is actually routing configured on this network. So do show IP route. So you see that is only locally connected networks available. You don't know anything about other networks. So that means this is nothing configured here. So we want to check show run actually. Well, you can go check run what is available, any configuration. If you want to check that, check it. So Up to now we haven't seen any router configuration. So this is the interface 00, which is connected to next router, and 01 is connected to our PC. And so router OSPF1 is configured and IP forward is configured. So router OSPF configured on this network. So fine. So do show IP OSPF, sorry, IP OSPF database. Okay, here it is. So it has a link ID, it has advertised router ID, and it has everything and sequence numbers, age, and checksum. If you check that, is it need to establish neighbor relationship. Okay, do show OSPF neighbor. So it is do not have any OSPF neighbor relationship. So that means that router may be something wrong, maybe something not configured properly. So we will jump onto router 1 now. Okay, here it is. We are on router 2 now. So we will check the configuration on this one now. Okay, here it is. Show it got everything, and okay, here it is. First thing, interface loopback 0. So this router ID is 10.1.1. If I explained yesterday, if you got loopback address is that's going to be router ID. Here is also 10.10.11. So that means both are equal. So something is funny on this router. So we will need to check that. Okay. And you will see the interfaces 0.2 and 40. This interface configured fine. No IP root cache, everything fine. So we'll check interface is up or not, and okay, then this interface is shut down. Okay, we need to bring that up also. Okay, we have to go through those steps. Okay, and one other thing I want to show here, no no IP root caches. So something is funny on this one, routing not configured. You see that no IP routing, so routing is not enabled on this router. So you have to enable router IP routing first. So config t IP routing. Okay, now you see that IP routing not enabled. We enable the IP routing now, and we found another issue. The interfaces which is connected to router 1 is down. So we have to bring that interface also. So we're going to router 2 interface, which one is connected to 00 gig 00 and no shut. Okay, that's it. I want to bring that interface up. If you see that it is doing some advertisements, so it is establishing something, but line protocol integrate is changed the state up. But we found another issue, the router IDs on both is same, so we need to change that next. Okay, interface loopback 0. We need to remove the IP address first. No IP address 10.10.1.1 and 255.255.255.0. Okay, we are removing invalid address, so we did something funny here. Okay, this is the one. Okay, 255. So I mentioned yesterday the interface must be 32 subnet mask. So thus don't do that mistake. And router ID we are changing to 1.2 now. So I'm changing to 1.2 now. Okay, now we change our router ID to 1.2, that is loopback interface ID. So then we will check do show anything is do show IP root. Okay, here is the IP roots, and I haven't seen any network is configured here, any OSPF. We will check OSPF also. Is any OSPF configured here? Do show OSPF database. nothing is configured. I think we haven't configured OSPF here, so we will configure OSPF now. Okay, so here is in router 1 we configured area 0, that is the same thing we are configuring here. And router OSPF process ID is, you can choose whatever you want, I just put router 2. Then network, we have two networks here, 192.168.40.0. okay, 0.0.255 area 0. Okay, then another network we got which is connected to router 1, network 192.168.30.252 and 0.0.0.3 area 0. Okay, now we configure the OSPF, we configured everything, and we will check how far we can we see any routes now. Okay, do show IP. Okay, you see that its adjacency, it is happen now, it advertise that route, and you will see that OSPF, it learn the OSPF route 10, 192.168.10 dot from this side, from here. If you go to router 1, you will see that also. Do show IP data. So you will see that is 10.1.1, and this is the one is you'll see everything, and you can see the summary also. If you see summary, it will sorry. Okay, here is the summary. Something is not base topology. We will check what is happening again here also. Do show IP route. Okay, it learns 40 now, so you can ping that from PC1, I hope. Otherwise we will go back again and check what is happening. Okay, it is going up to 30.254, but it don't know about 40.5. Okay, we will check. Actually, is IP address configured on this PC? Yes, I show IP. So that is configured. So something is funny going on. So we need to investigate again. How far we going now? Okay. So we will trace it again. Trace 40.40.5. We're going to 30.254, and we're going not reaching 40.5. But it is showing that ICMP and everything destination port is unreachable. So we will ping that now. Sometimes tracer won't acceptable. So we will ping now 192.168.40.5. You see that we can ping it. So we successfully finished our OSPF configuration from PC1 to PC3. That's it for this lab, and we will going to discuss OSPF multi-area. I hope you enjoy this lab. I hope you solve successfully. If you struggled anywhere, please follow walkthrough steps and go step by step to solve this problem. Okay, that's it. We finished this one now. Okay, I haven't saved any configuration, so I'm switching off this. I will upload this solution also. Uh, I will upload this solution, so if you want you can download it, and you can uh, you can check your configuration, what we done here, what commands we used. Okay, I'm doing the on both one blur. So if you don't save any configuration, your routers won't save it, so that's why you will struggle everything again. You need to do it from beginning. Okay, so we haven't changed anything on the PC, just we struggle step by step this one. Okay, I'm stopping this one now. I'm exporting. You guys know how to export this project, portable project. Now I'm exporting. What is this? OSPF solution. Okay, this is a project. I will upload. If you have if you have anything, please download and check yourself. Okay, that's it for this solution now. Okay, we're going to OSPF multi-area. Okay, Why OSPF multi-area we will use? What are the benefits actually? Yeah, the main thing OSPF multi-area, the purpose of OSPF multi-area is we summarizing the big networks into small chunks. So when you make it small chunks and advertise, you are isolating those are network advertisements into small areas, so they won't advertise old routes. Whatever happened in that area, it won't advertise to other areas. So some of the one router, the border area border router will stop those advertisements and it will summarize whatever changes happen, then it will publish into that area, so it will stop broadcast. That's the main benefit of OSPF multi areas. Okay, and another thing is it will improve the network latency, it will improve the network speed, it will tune network, and that's main thing. And another benefit is some of the securities also came inside, like that if is anything is not broadcast whole network to the untrusted. Sometimes if you leak anything, you don't leak every data to the and every network to the outside one. Okay, so what is the main routers in this one? OSPF router types is in the OSPF all topology. What are the router types? Internal router. It is responsible for maintaining a current and accurate database. Every database of every LSA link state advertisements within the area. Whichever is mainly is responsible that area LSAs. Yeah, forwarding whatever it is has whatever the accurate data it has, it will advertise. That is mainly this one is DR. It will designate a router. Okay, then backbone area. The design rules. Backbone is a main connector. That area needs to connect through every single area in the OSPF design. So this is a backbone area and router within that area as a backbone router. Okay, the which is sitting in the area 0, whichever that is also DR in that area, and also the whatever the DR is also a backbone router. And another one is area border router, which is sitting in if you put that one, if you put another router here. So if I take this another router, so if we assume that this sorry, lower one layer. So if we assume that this this area is another one, and this area is 0. If we assume this area is 0, 0, sorry, area 1, and this area is 0. If you are assuming uh, this area is 0, area is 0. Okay, if you assume this area is 0, if this area is 1, this R1 router becomes area border router, which is summarize the routers from one area to the another area. It won't broadcast everything into that area, so it will summarize the routes, whatever changes happen, then it will send those changes only to that area, other it won't send everything. So that's the main purpose of area border router, and that is the main dividing these areas is main features and main benefits. And another thing is autonomous system boundary router. Autonomous system boundary router, where it comes mainly in a main big networks, it is sitting in the near to the it's sitting in the area 0 most of the time, and it will connect to the internet outside the outside world. So that is autonomous system boundary router sitting the router sitting there. Okay, and what areas we have in the OSPF, there is another thing I am going to explain, that OSPF design considerations and what areas do we have here. OSPF as a area 0, that is a backbone area, what that is called standard area or uh, ordinary area. Area 0 must be advertised those to other things, so there is no stopping. The other area types are stub area. This stub area it do not accept external summary routes. Okay, the it, it will won't accept externally summary routes into the internally. That is summarized by ABR. Whatever the ABR will summarize, and sub areas routers will only use whatever the ABR summarize that route. Those routers are only use that summarization or route summarization. So why this if you do that stub area, the very less resource routers. If we do not have a high power router, or if you do not have if you have any slow router, you can put that into stub area. So you don't need a heavy CPU power on the router. You don't need any processing of routers and those things. So you can use less power routers in stub areas. So that's why you can save some money. If you think about money wide, budget wide, you can save that, and you can put high power routers on ABR side, like area border routers. And totally stub area, and this area do not receive any LSS from the outside world. It won't receive a totally stub, is completely stub, only ABR will send some whatever the ABR will minimize lots of advertisements, and it won't send it. It will capture the advertisements and summarize the routers and send whatever it needs to internally totally stub area. Okay, it will only summarize route. It will only change default routes only. Yeah, it won't advertise even. It only advertise default route to this totally stub. So you can save you can put small routers in totally stub areas for not you don't need enough big storage to store routing tables and RAM, CPU, whatever it is. Not store stub is areas. There is another area, not store stub area, and this will accept some advertisements from the area 0, not from normal areas, like type there is a LSS, there is lots of type of LSS, link state advertisements. So you need to go in deep, but you won't get this one in CCNA at the moment. I hope CCNP, whoever writing for CCNP, they will get what is the LSA7, LSA5. These link state advertisements is about the network summaries and autonomous system external AS external routes and external link state advertisements like this. But not just we will receive some of the advertisements from area 0, but not everything. Only LSA 5 or LSS 5, LSS 7s only. Okay, that's only this is only the some of the areas I explained that. But if you go into deep is more deep, you can mm, get into when you go into further CCNP or CCI, you need to go into very deep. Why LSS 5, what are the LSS 7, and how to restrict them, how to tune them, and those things again. Okay, another thing, the main thing, OSPF configuration is easy, but the designing is more. You need to think about very accurately what it will. OSPF will, the main consideration is design, how to divide the IP address, how to summarize the IP address to how to summarize the routes, and also what routers you have to use, how much CPU do you need on router, how much RAM storage you need to. So why I'm telling that is it will store all the routes database in the storage and RAM to process the all the routes. So you must plan very carefully about which router you need to put as the ABR, which router is DA, and what is capacity you need put it on, and number of areas. Okay, in exam or whatever labs we will explain that this is router 1, router 2, but when you come to the real world, this is not like that. They will how it looks like is I will explain that is normally. they put the web layer. This is a web, and next app layer, then app layer here. Then sometimes they put database here, database layer. Yeah, these are only some I'm talking about. Sometimes they will connect this web layer into internal some of the network. I know that some of them already connected some core layers here. They got all infrastructure like that, or sometimes they will connect this one web app database. Normally that is a modern structure they're using. Some of the people they use like this. But if you consider like this, if you choose area 0 is here, this one becomes another area. Okay, I'm using the another one. So if you choose area 0 is here, this one become another area for that one. Okay, so that's why they will consider, they must consider where is the most of the routes. If is the application layer, how to summarize these routes and networks, how to divide the routes. And I'm not they won't have only single web or app. If they're going to, if it's a big company, they will have lots of the layers of test environments, and they will do pre-prods and productions and lots of environment they have all of the environments with web and application, and then they got database. So you can understand if it is a production got one, that this one, if production got all this web app database, and our tests also same thing like that, pre-prods test and regression test, vanilla test, they have lots of names they will put that, and big companies. Okay, that's why. So when they thinking that much big, they must think where is the root area 0 and where is the areas 1. So how to communicate backbone infra areas. Okay, so that's I'm telling. In the real world, this is totally looks different. Okay, please think about more, think about more how to think, how to plan it. But in the CCNA wide, this is more tough to understand at the moment. But if you once to get into real world, and if you get into CCNP, you will understand how to divide these areas and everything. And that's it for, I'm not going to bore you more on this. I'm not going to teach you more on theory about I don't want to bore you. So I'm going to jump on. We will configure one multiple areas configuration. Is just like just extending the area and adding the area. Other than that, you won't see that much difference in configuration. So if I go to the same okay, we will take the same network. I'm not worried about to change this one now. Okay, this one we will done that. This is, if you consider this one is area 0. Okay, if I put this one, we will change, configure this. I'm changing this name to route 3 now. Okay, so okay, router 3, if we consider as area 1 this one. So I'm switch on this one now, start, and I'm not changing anything, guys. Yes, I'm adding the extra router here. Then we will connect this one to 002 again here, and 03, excuse me. And I'm putting another PC here. Yeah, we will put this one, and we will also connect this one with 01 to Ethernet 0, and we will start this one also. Okay, we configure this router connection here is 192.168. I will put this one. What we configure, we use the 192.168.30.252. Okay, we are going to use between these two routers 192.168.30. What is the next root network available for us is 252.248. So we can 248. Yeah, you can use 249. Yeah, 248. We can use that network. We will use that network here now. Okay, so I'm starting this one also. Sorry, I forgot to switch on these routers. Start. Okay, we'll start these PCs also. Okay, I'm starting everything, but I haven't configured anything. First we will configure this one, this router, whatever the router 1 we got. If I'm boring you, if I'm anything, if I'm going very slow, just change your video speed to times 2 or times 1.5, so you'll go a little bit faster. But if the people who do not understand, please follow the same process. Okay. Okay, config t, yeah, and interface we're going to first configure the interface, which is configured 03 interface gig 03. IP address, we chose that 192.168.30.249 for this site. Yeah, IP address 192.168.30.249 and 255.255.255.252 is a subnet mask. Okay, and no shed, please remember, sometimes if you share the if you don't put no shed command, it will be sitting there and that will happen. Okay, and an OSP, we need to configure this as a area 1, so we will think that this is a area 1, so we are configuring to root OSPF and sorry, so what process we using on this one, just I'm checking that to show OSPF database. Sorry, I put the IP, I need to put that IP OSPF database. So I'm using area 0, process ID is 1. Okay, so I'm going to do that again. Router OSPF, the same process ID. I'm not changing the process ID. I'm using same process ID, and we're going to add network 192.168.30.248 and 0.0.0.3, and this is area 1. Okay guys, so that's why I'm saying that. So this is, we are putting into area 1, this one. Okay, if you see the summary, it will goes to area 1 here. Okay, so then we configure this router, everything done. We jump onto router 3 now. Okay, I'm closing this router 1 and we're going to jump on router 3, sorry. We haven't configured anything in this one up to now. We nothing doing. Okay, we are doing now config t, and we need to first configure the interface which is connected to router 1. Okay, interface, what is connected, 00, we connected to router 1. Interface gig 0 0, IP address add ress 192.168.30.249. I'm using 24, we use 249 there, so I'm using 250 here. Okay, then 255.255.255.252. Okay, and no shed here. Okay, that's it, we're done. We configure that interface. Next we need to configure whichever the interface which is connected to PC4. Okay, then interface, what is that, is we will use 50.1. I'm not changing. If you want to change your IP address and try with a different thing. Okay, and gig is 0 1. Okay, IP address 192.168.50.1 255.255.255.0 no shed. Okay, we configure both interfaces, both are up. Then we need to configure our routing protocol. Okay, so I'm doing router OSPF. You can put any process ID, doesn't matter, I can put one also here. Process ID no need to match, you can do anything, but you must match areas to broadcast your establish the neighbor relationship and establish the exchange LSAs and everything. Okay, then we adding network 192.168.50.1, sorry, 50.0 and 0.0.0 255 and area, this is in area 1. Okay, so and another network we are using, I'm just changing the small values, I'm not typing whole thing. So we are using here 30.248 network. Okay, that's it. We configured OSPF area 1 successfully on the router 3. Then we will check communication actually is it working. So I said that is simple. You see that link state advertisement going on, but I haven't configured our loopback address. So I'm going to do that interface loopback 0. Okay, IP address 10.10.1.3. I'm just following the serial numbers from there, 255.255.255.255. Okay, so we configure nearly everything and we will check the connection on this one first. Sorry, I'm going to check we're going to configure this PC first. IP 192.168.50.5 and 255.255.255.0 and gateway 192.168.50.1. Okay, that's it configured perfectly now. So we will ping gateway. Actually we are connecting, we are communicating with router or not, we will find that one first. Okay, that's successful. Then we will check our what is the IP address we configured on this router interface is 249. Okay, so we will check that. We are going to step by step. Sorry, sorry, I haven't switched on this one yet. We will switch on that one first. And okay, we're going to do that now. 30.249. Okay, successfully we came from this place to this place. So from here to here we came. Okay, from sorry, from here to here. So I'm not good in drawing here, sorry, I'm deleting that one, sorry. So we came from PC4 to router 1. Then we will check, jump onto this one, and we will check what is the communication here. Whatever is the PC3, this is the one PC3, we will check communication from this place. Okay, 40.5. You see that successfully we configured everything, but sometimes you will struggle, sometimes you will forgot something not properly done. That's configuration simple, but when you are designing this one, you must think about properly how to summarize the router. If it's a big network here, if you got so many networks, like if you got some of the web layer and app layer routers, if you got so many routers here, so you need to consider, you can't advertise everything into internal. If you got any infra, your data center is here, you can't publish everything into your secure database layer. Yes, so you need to put something stub is there or something like that. You need to think about that. Okay, if it's something happening broadcast happening in test area, you can't bring that everything into production routing, production firewalls or routers. So that's why I'm saying, you said that our firewalls is there, but firewalls or routers are different. They will share the routing information. Okay, so every router is not high capacity. They won't buy some of the companies don't spend that much budget on every router. The core routers are different. Some they use small routers on different areas, so that will save the budget and everything. So what is next thing is I'm going to explain how to verify this OSPF and everything, summaries and everything. How would you do that? And thus we are going to discuss in next step now. Okay, the main command is you will check OSPF database. We explained in the previous tutorial also, and also we're going to see some more commands here, and also there's not that many commands we can other than that previous video. Just you will see the show IP. I'm coming from this place now, router 3 we are. Okay, show ip root is the main command. It will show you everything values. So I'm just going to explain the what is the use. In the previous video it is only O, that means is OSPF. Why IA came now, there is, you see that in video here is IA. So what is this IA came from? Actually we are in router 3 but it's supposed to show only O, but here is this root is learned from this router, from this internal router. This is internal. IA means internal autonomous internal autonomous router. Okay, so that is why if sometimes it should be EA, that is from external domain, external autonomous external domain that root learned from. So this router learned that root from this internal autonomous number. Okay, so that is why you see the IA here. So these all things are coming from internally, from our, we are using only single, we are not going from, this is all in area 0 is connected, these are not connected to any other areas. Okay, so that is why is internally. And you can see this one, your router ID where is 1.3. Yeah, I will explain that. Sometimes they will ask in exam in different way. You know that this is a loopback address which is mentioned here also, and you will see the 32 is a subnet mask, so that means is a loopback or router ID. We use that one. Okay, and if you see here, show IP OSPF border routers. So I explained that this is router 1 is area border between 0 and between A. So 10.10.1.1 via 192.168, this is the network. Yeah, this is the ABR now. This is the area border area 1 SPF 3. Okay, so you must think about this one. I mentioned that inter area route I. So you see that I is here. So that's why I'm explaining. So if in exam they will ask you which one, what, how would you check that area border route, or what command, sometimes they will ask you to do that. Okay, please remember some of the commands. And how would you tell that what is the um, with the what is the with the ID one, what is the border router ID, or some of the information they will ask you. Okay, please be careful, go to the each tab and each line how to check. Yeah, and the some of the border routers you need to check on external, some of the uh, virtual links also if is a, but I'm not explain any complex scenarios here, but sometimes they will ask you show IP OSPF virtual links. So sorry, virtual links. So we do not have any complex scenario here. Like if I explain that here, if you got one route from this place to one connection from this place to here, yeah, and is another connection from this place, I do not have enough connection. So if is another connection from this place to here, yeah, if is another connection from this place to here. So if packet traveling from this to here, which route, which path does it use? Does it use this path going from R3 to this router and going here, or going straight from here to here? Okay, think of those virtual links will establish, it will show you everything. Okay, and another thing is what is show IPA OSPF database. I explained that. And sometimes it's IP OSPF network. Sorry, what is the console again? Show IP OSPF network. Sorry, neighbor is, I explained that yesterday, is a, this is a state, whatever it is OSPF state. If you see the full here, that means the neighbor relationship established completely, this is successfully established. Please remember that one. And this is a dead time interval. If is next 38 seconds, it will receive another one, another advertise or another dead time is a default time. I explained that yesterday is 40 seconds, so dead time interval is 40 seconds. So in 2 seconds I think is a countdown time. In 2 seconds it will receive that. If you see again, so you see that 36, it will change every time. Okay, if you see again, it will go 31 seconds. So in next 31 seconds it will receive another one. Okay, uh, so there sometimes they will ask you this, give this screenshot, and they will ask you how many seconds it left to receive next dead time interval. Okay, so please be careful when you next we go into OSPF database. Here you will see everything in database area 1. This is a sequence number, and this is a checksum and links count, how many links and link, which link is going to yeah. So you need to go to, this is age in how many I think it's seconds, is how many seconds is going to expire, or how many seconds you will expire this sequence or advertise. Okay, so familiar with these all the things, so you will verify easily if is anything happened wrong or during the troubleshoot or anything. And sometimes if you struggle with anything, you need to enable debug, or sometimes say you see the log if you want to see any logs in that area only, if you want to go to uh, if you want to see every step by step what is happening, that so you have to enable logs also. That is only simple. If you go to the router, if I'm going to router, what is sorry, I mean not config t, and sorry, I put the wrong one, config t, and we're going to router OSPF. I think we used is process ID 1. Yeah, OSPF process ID is our 1. Yeah, so what I'm doing, I'm enabling log here, log adjacency. Okay, log adjacency changes. Okay, so which network we will do here, I'm not doing anything. We want to do everything whatever we do. Network, okay, this is 0.0.0 and 255.255.255.255 dot area 0. What is happening in area 0? I want to see everything and end. Okay, so what happened, you will see console by whatever is happening. So what we will do here, we will disconnect one network here. So what I'm doing, sorry, I can't show you both at the same time. Okay, sorry, it's not happening. So I'm deleting this link, and so we will see what is happening here. What is anything happen? Nothing. So we not put down the network. So what I'm doing, we're going to console here. Okay, so we are in router 3 here. Sorry, config t. Yeah, and what we'll do, we'll shut down interface. Which one we doing? Interface gig. So what interface on router 2 is previously it was connected to, sorry, I missed this one. Okay, 02. Okay, we will come back here again. Okay, interface gig 02. I'm going to shut this. Yeah, we will shut it down. So we will see how much time does it take to our link file change interface change state to administratively down. So we'll change. Does it affect anything here? Advertisements, does it change anything? It will advertise or not? Okay. So we will see IP OSPF root now. Show IP root. So it is not happened yet, but it is root there, but is not saying anything about 50, 50 is here. Sorry, it is 40 network. So you see that you don't see any 40 network here. So it got immediately, but we haven't seen any logs. That's why I want to show some logs, but it is not happened. I don't know why, but we will debug that. You can debug that adjacency changes. I did that, but it's not happened here. So we'll we will disconnect this network now. We will shut down our 00 here. Okay. Interface gig 00. Okay, and we will shut that one. Shut. Okay, neighbor down, interface down. So it is showing here, but is not establishing any logs here. Maybe it's going into some null or some black hole, or maybe the router not published. So we seeing everything there, but we are not seeing here. So this one got everything. Neighbor is down, process one is down, loading done. But okay, this is it is going only from adjacency, not from the other interface. So that is why OSPF not publishing from area 0 to area 1. So that is why it's not happening. So if you do anything here on router 1, maybe it will bring that down. So we will see. We will bring that this interface. Okay, what is happening? Area 1. Sorry guys, I'm just boring everyone. Uh, interface. Sorry, interface gig, which is 03. Sorry guys. Oh, my typo mistakes today again. Oh. Console is R1. Okay, I just want to show something about the logs, but it's only interface gig ethernet. What is the ethernet we connected is 03, and we will share that. Okay, I shared that interface OSPF adjacent process 1 neighbor root on giga ethernet is detached. Okay, we're getting every logs here, but this is not is ABR, that is ABR. So I don't know why is logs not showing. I will debug that later. Sorry about the I'm boring you guys. I just want to show some logs, but it's not coming. That's it for this video. If you have any suggestions or if you have any comments, please put them into description. I'm not doing any assessment for this video. The thing is, if you want to give that, if I want to give that is more complex networks, that is not for. Oh, you see that this is after. Okay, the 40 seconds dead interval. Sorry, 40-second dead interval is kicked in now. So this is happened now. So you see that. Okay, that's it, guys. That's I just want to show that one. That's it happen now. Okay, that's it for this video. Thank you for watching this video. Please subscribe for latest updates on networking and CCNA side. Thank you very much for that. Bye.